All right. So our next one is problem 32. Um, so a little bit of a story problem here. We have a pendulum, right? So something hanging down, swinging from side to side. And we get this word directly proportional. So that means something is equal to some constant times something else. All right. So the period, P, the length of time it takes to complete one complete swing, is directly proportional to some constant times the square root of the length, right? So period, the amount of time it takes to make one complete swing, is constant times the length. So they give us an initial thing here. The pendulum that is 8 foot long, so that's a length, right, is going to have a period of 2 seconds. Okay, so this allows us to find the K. 2 is K, and this is like 2 radical 2, right? So we divide both sides by 2 radical 2. So K is equal to 1 over the square root of 2. So now we have a formula. The period is equal to 1 over root 2 times the square root of the length. Now, they get clever here. They say, okay, write a mathematical expression expressing the period as a function. So we did that, made by a pendulum 2 feet in length. So the P would be the period, and if it's 2 feet in length, that means we're going to get a square root of 2 here, which means the period is 1 when I'm 2 feet in length. So this means that it's going to take 1 second to go from side to side. And the question asks me the number of swings per section made. So it's 1 swing per second. So though the problem's trying to be a little tricky because the period is number of seconds per swing, because it's 1, the reciprocal of 1 is still 1 swing per second. So there you go. That's problem number 32.